The following is brought to you by Total Seal Piston Rings, the leader in ring seal technology. TotalSeal.com. Hello and welcome to Hidden Horsepower. How's everybody doing out there? My name is Joe Castello, and this is our first studio edition of Hidden Horsepower for 2023. And I am not here alone. Oh no, Lake Speed Jr. joins us now. Lake, welcome back. Hidden Horsepower. We did the Engine Performance Expo. We had the holidays, and now we're ready to ramp up as the racing season ramps up. Everybody's getting ready. They're putting their new engines in their cars, and we're learning a whole lot, and we've got a nice episode for everybody here today.
Oh yeah, today's all about executing on what we've talked about at the expo, empowering people to go to that next level. In fact, right here where I am today is Hill Country Machine. Elaine and Daniel Solis, their shop right here just outside of San Antonio, Texas. And we've been actually working on is, okay, you know, these ideas, these concepts of surface finish and, you know, utilizing the tools that we showed off at the expo where we're able to use the profilometer and the microscope and incorporate the software we talked about on the last studio edition of Hidden Horsepower. Me and Matt were looking at how you can see the trace and you can use that to hone. We're doing that right now. Say, hey, you don't always have to have $100,000 CNC hone in order to get the correct surface finish. So what we want to really be able to do for 2023 is go beyond just talking about these concepts and really start helping people enable it and make it real. Because, you know, going back to the expo, man, we're still blown away. We picked up Dad's engine, 300 horsepower. We picked up the Engine Performance Expo LS, 300 horsepower over the course of the year. So big gains can be made when you know what levers to pull, and that's what we want to do. Let people start grabbing those gears. Let's make some power. Make 2023 real.
Absolutely. Well, we all had a great time at the expo. Hopefully the audience out there enjoyed the throwback to the year before, and we'll be doing that again in the future. Many of the interviews that we did at the expo, one person that was like a big star of the expo, I wouldn't call it like a breakout performance because he was a big star already before, was Mr. Ben Strader, and he is going to join us right now. Ben, welcome to Hidden Horsepower. How are you?
How's it going? I'm doing super extra good. Thanks for the great intro, Joe. I feel special now.
Well, you should. You did a great job. You carried a lot of weight, and I checked the social media traffic that was going on during the Engine Performance Expo, and I saw a lot of people like, man, this Ben Strader, he's doing a lot of stuff, man. He's carrying the show. He's doing it all. You're a media talent, of course, but the knowledge and, like Lake said, right, it was the results that drove that. The result was amazing.
Yeah, you know, I was just trying to help out Lake because he was running around, and rarely do you ever see Lake running out of energy, you know, but man, that's a long couple of days to be on the whole time. And so I just kind of told him at the beginning, me in whenever you need me, and I'll just ramble on and talk about stuff, and, you know, it'll be fun. And sure enough, we had a great time.
Are you saying
I used him up?
Are you saying that Lake ran out of energy? Is that what you're saying? Because I don't know if that actually happened.
I'll bet you that you don't remember your head hitting the pillow that night, Lake. It just, you were done. Yeah,
I was done. Yeah,
rare. That's a rare thing for Lake.
Yeah, well, there was a lot of hustle. There was a lot of work behind the scenes. But, you know, my job is it's pretty easy, right? Linking it all together, making sure it keeps on moving. But you guys behind the scenes with the work and the dyno pulls and just like giving that final punch. Again, people out there in the audience can let us know, obviously in the chat section and on social media, but I enjoyed the Engine Performance Expo greatly and learned so much, so many great interviews. Can't wait to do it again next year. But now it's onward, right? There's a lot of information that we learned. And like Lake said minutes ago, how do we use it, right? Let's put it to good use here in 2023.
Yeah, you know what's really interesting is it's hard. Anytime you go to a training or a school or listen to a lecture, watch a video, whatever, it's hard to retain everything on there. I mean, there's so many like moments where you're just like, oh gosh, aha, you know. But I think what's cool about that Engine Performance Expo is how you can go back, not just to the stuff we did this year, but man, all the way back to the first one. Every single episode on there is still available. So the ability to go review was pretty spectacular.
Oh, absolutely. Lake, your thoughts?
Well, somebody I met one time said something about, you know, we teach what we're most interested in learning about. I think that guy's name is Ben or something like that. I don't know. But that's really been the driving force behind the expo. If I'm being honest from my own personal, and I know I'm going to speak for Ben here, the reason we do this, we put so much time and effort into it, this is the stuff that we find fascinating, that we want to learn about. So we go, full hog, go crazy on trying to do these crazy projects and, travel across the country and do these kind of things because we're excited about learning it. And what we want to do is, back to the empowering thing, we don't want to make it just conceptual for everybody else. We want to do some things, and we have some things coming up here in the next few months where you can join us and start to actually hands-on make these things reality for you, not just something you're watching.
Well, don't hold back. Let's get right into that, right? And that has been a question that has been asked by many of our podcast audience. And I get out to the racetrack. I was out at the racetrack this past weekend, honestly, dating the show a little bit. It's fine. First NHRA action of 2023, Orlando Speed World divisional race. And just amazing, the people that I was able to connect with that weren't necessarily like, of course they're NHRA fans, but they were fans of Hidden Horsepower. And they listen to the show every week, and this is when they come out, and this is exactly what they wanted. Like, how do I come hang with you guys? One gentleman was right near Straub up there, and he's like, could I have just he has a machine shop. He's a veteran machinist. Could I have just come and watched it? And I told him,
you could have come hung out. Yeah.
You could have come and hung out. That was kind of the point. And so to get your hands a little dirty and start doing this stuff, what do we got planned?
Well, the first one is in Lake Havasu City, Arizona, where Ben is, the competition engine development class. So I'll let Ben explain what it is, but I can tell you this, because I've been to it before, and it helped me a ton. It's not a blueprinting class.
No.
So this is not something you need to make the trip to Havasu for if you want to learn how to blueprint an engine. This is really about how you can unlock that hidden horsepower, the right way to think, and what kind of tools are involved. So Ben, why don't you explain what the thought process is and what's going to happen in Lake Havasu on this deal?
Sure, I'd love to. Part of the reason that we started doing this class, Lake, is that I was asking the question: if you're a young person in this industry, or for that matter, a grown up, and you really want to get to the next level, how do you learn the right things to do? How do these guys that have made all the successful engines, how do they know how to choose the right cylinder head? How do they know how to choose the right camshaft? And, so many times you get answers like, well, you just kind of got to have some experience. You just kind of got to know that. And I was never satisfied with that. And so frankly, I have built here, this facility is the kind of place that I wish there would have been when I was coming up and learning all that stuff. Yeah. So effectively, just a grown up, Disneyland for adults kind of thing of car guys. But ultimately, the class was about how do I cut through all the white noise and use real science and real math and a real thought process to be able to unlock and achieve bigger power numbers, reliability, all these kinds of things, efficiency of the engine that most people just say, well, you just sort of have to know. Well, there's got to be a way to get from A to B and B to C. So that class, competition engine development, you're right. I think the way you described it is perfect. This is not blueprinting. This is not how to build an engine. If you're not sure which end of the torque wrench to be using, this might be a little too advanced for a first class to take. And I'm not trying to be, a jerk about it, but right. We're going to take a scientific and a mathematical approach to understanding engine efficiency. We look at mechanical efficiency, friction and drag. We look at volumetric efficiency, airflow. We'll look at thermal efficiency, capturing all that heat that we're making. And then we'll use real world data to sort through the how. A lot of what we do in the Engine Performance Expo is the what and sometimes the why, but we just don't have enough time to really dive into the how. And so this class is a 3-day, adventure through what do I look at? How do I evaluate whether or not it's right? If I was going to start with a clean sheet and I had a goal of power to make, how do I use my calculator to get from 0 to 80%? You know what I mean? And we know it's not perfect. If we could design engines with calculators, we wouldn't need race cars or dynos or whatever. but we still have to have a way to get there and get the package together the right way the first time. And that's really what that class is. And, you've been there. We talk about all kinds of stuff, the mechanical side, the airflow side. We got the Spintron data to look at. So that's one of the picture right there, Joe, is that new 7.3 liter Ford Godzilla engine that we've been running on the Spintron, so we can evaluate the valve train. Wow. All these things are stuff that we look at in this class. You'll see firsthand Spintron data, dyno data, in-cylinder combustion analysis data. We're going to learn math formulas. We're going to learn all kinds of tools that you get to take home with you. And, there's the brand new CWT balancing machine. So we're going to, again, looking at putting numbers on things that we can manage and control. And I think that's important. So often it's just, well, you just sort of have to know. Well, that's not really fair for the young guy that says, where do I start? I don't know because I don't have any experience, but I can't get any experience because I don't know. There has to be a path forward, and that's what we tried to create in this class.
That's great.
What's great too is it's not just all talk, a bunch of lectures. I mean, there are some of that, but it's also a chance to touch the machines and talk to the parts, and it's hands-on too. So it helps it bring it all together and make it real. That you're not just watching a video. You're really in the shop and you're able to look at the parts. And I mean, like little things like your Keyence microscope there is amazing to be able to look at what a part looks like under 200x magnification and start to put it all together. Because to me, that's what I think this class is so good about, is it's taking all these different parts of the puzzle and it's where they all starts to kind of come together. And you can leave out of there knowing what to do, because now it's not just these little pieces of information that have been scattered all around. It's all come together and you can take action and go forward from there.
Yeah, even like you mentioned the microscope, even be able to do post-mortem analysis. Okay, so we screwed up and we have a failure. How do I know where to go work on something to make sure that doesn't happen again? Instead of just going, I don't know, maybe it was just bad parts, or I don't know, maybe parts just fail sometimes. We need to have an answer so that we can prevent that catastrophic type stuff from happening more than once. And so we'll have real world examples that you'll get to look at under the microscope. We can point out things that you can look for before you assemble your engine, right? So again, like you said, not everyone's got to have $100,000 hone to get results. Well, you don't have to have a $10 or $15 or $20,000 microscope, but there are things you could be looking at that would save you a whole lot of trouble in the long run. And that's the kind of stuff we'll get to do hands-on. You'll get to hold the part and put it on the microscope and look at it.
So where's all this going down, right? Like I like to put myself in the position of, and you said it, Ben, and not that the older gentlemen out there don't want to learn, certainly not, but they also already have a great amount of knowledge, but we're trying to replenish the engine builder, the blood of the engine building craft, and to get those guys interested. There's now no excuse for not doing it because the information is there, and we've already announced that there's a whole bunch of people that want to help, and they're all on board. Like, we want to help you. We want to help you. So you're doing these classes. Where are they? When are they? And for people that are interested, how do they get involved?
So the where is right here at our facility here in Lake Havasu City, Arizona, which is about 2 hours or so from Las Vegas, Nevada. And it's difficult to teach this particular class at other places, Joe, because, man, the amount of equipment and resources that you need in a facility to do all of these different jobs is tough to replicate. So again, I just sort of built the kind of shop that I would want to go hang out in all the time. And Lake will tell you, he comes over here and hangs out all the time too. And at the end of the day, the when we do the class several times a year, the next one's March 1st through the 3rd. It's about half sold out already. Actually, I think there's only 3 seats or so left. We cap the size at 6 so that we can do a lot of time hands-on. But it's like you said, Joe, it's the series of steps, the dependent events. How do I learn how to get from step 1 to step 2, step 3? Well, if I have 30 years of learning the hard way, that's one thing. But if you're getting started and you don't have those 30 years, where do you even begin? And that's kind of what we wanted to build here. So, come out, hang out, put your hands on stuff, play with it, learn that way.
And if you've never been to a NASCAR or NHRA Pro Stock engine shop, just go to the class. You've essentially done the same thing. Because that's one reason why I love going out there is it's all the tools. short of the ABL dyno, which most pro stock teams don't even have those. It's everything. There's not many places you can go, and there's in-cylinder combustion analysis happening there, having the spintron, having the Keyence microscopes, and all the other. Like I said, it is Disneyland for people who love engines. So that's Disney World plus Epcot and all the other stuff.
You get the 3-day pass. Yeah. That's really interesting that you say that, like, because that's a good point. It's not like we're just like auto shop class in high school where we have all these old sort of relic parts so the kids can play with. I like to think that we're building engines at pretty much the highest level of motorsports here. We don't have a ton of customers, and that's by design, but the customers that we do have race at a very high level, and they're very competitive. The engines that we're building here run at the front of the pack in all the classes they run in. And so I like to think that if you knew you could, let's say you knew what was inside a NHRA Pro Stock shop. How many guys do you know, Joe, that could say, I'm going to ring up the phone to KB Motorsports or Elite Motorsports and just see if they'll just let me go hang out and look over their shoulder? Like, not happening,
No.
And so what we tried to build here was a place that was like that, but that you could come knock on the door and come in and sit down for a couple of days and ask questions. I almost said ask dumb questions, but there really aren't dumb questions. I just mean sometimes as guys, we're afraid to go, hey, I don't understand. Can you tell me? And have somebody stop what they're doing and explain it to you. You're not going to find that in one of those types of shops. So we had to build it ourselves so that, we could find those answers and then share them with people.
Well, that's a human thing, though, the not wanting to slow down the process by asking a question. Lake knows it from the NHRA Trackside Tech Talks that we did, that they would go through this long, not long, but a presentation, and we'd say, does anyone have any questions? And no one would have any questions. And then one guy would have a question, and then the next guy, and then the next guy. And then next thing you know, they were there 30 minutes after it's over answering all these questions. It's just nobody wants to be that first person. That's the whole point of this exercise, is to go through it and delve into the questions.
Yeah. Well, the great thing I mentioned about Joe, sorry, Ben, is that unlike doing a trackside tech talk where we can do a presentation and then eventually people do open up and they start having their questions, but we have to talk about those things. We have to talk, maybe show a picture or do this and try to explain to somebody what it would be like to have the profilometer and measure a cylinder and then hone out a couple of thousandths and then do this and do that. At the class, you can hands-on go do it. You can literally go grab the profilometer, go over to the cylinder bore, and you can check it yourself. So that's what I'm saying. It's that next level of going beyond just head knowledge and then actually getting your hands on it. That's what makes these classes so cool.
So, the picture is worth 1,000 words, right, Joe? Bring up the picture you have of the spintron data with the yellow line at the top that looks like like the gear. Nope. The other one with the yellow line at the top, the black background. There you go. So that spintron data that we produced here only about within the last month or so. Like the ability to go and actually make the gear changes on the spintron, it's unheard of. Almost no one can do that. Some of the cup teams can, but I mean, you don't see spintron data with gear changes like this. And so in the class, it's not like you're looking at old relic, this is how they did it in the 60s type data. We're learning as fast as we can get it in the classroom. And so what happens is whatever you learn, we probably just learned within the last year or two as well, exactly. Because it's cutting edge technology.
That is amazing.
Absolutely.
That is amazing. And yeah, guys, just call up pictures and I'll do my best to get them on the screen as fast as is possible. And Ben, I know you sent a couple of videos as well. And Lake, you sent a video. We got a dyno pull as well. So we'll keep people going. But I find it to be interesting. And the interest is out there, right? Like why? One thing that I think is common about, we'll call them younger folks, but really it's the modern generation or anyone that's operating, is they're looking to be as efficient from where they are to where they want to be. I won't call it a shortcut, but as efficient from where they are to where they want to be. And trial and error doesn't sound like a good, efficient way to do it.
Well, in video games, right, you're looking for the hack, right? How can I do my life hack? How can I get to that next level without having to go through the trial and error part? Well, this is it. This is the hack, right? You want the hack for building horsepower. This is it. When the thing is, so if you want to know about the dates and how to sign up and do all that, I don't know if Ben mentioned it, but it's EFI101.com is the website. Isn't that right, Ben?
That is correct. Yep. And then there's a tab for schedule and locations. You can come find us on there and get registered. So, like I said, the easiest thing to do is fly into Vegas. There's lots of flights in and out every single day. So fly into Vegas, rent a car, come hang out for a couple days. Usually the weather's terrific. The food's good here. And we just spend a ton of time hanging out in our really cool shop looking at really cool data.
Yeah, tough sell right there, right? Flying to Vegas. Yeah, flying. Oh,
Yeah,
and by the way, you're flying into and out of Vegas. No, it makes perfect sense. Did you say it was EFI?
And yeah, you can spend the weekend there if you wanted to, right? If the class starts Wednesday, Thursday, Friday. No one says you have to go home on Saturday.
That's right.
Yeah,
that's right. Yeah, that's right, honey. It's over on Monday. Yeah, I'll be back. Did you say EFI101.com?
That is the correct website, EFI101.com.
Excellent. And we'll put it up on the screen, EFI101.com.
And that's just the competition engine development class.
That's right.
As we announced at the expo, we're also going to be doing 2 hands-on honing classes, just 1-day class strictly on honing. So Ben, why don't you talk about those?
Yeah. So the idea behind the honing class was to be a little bit more focused. Behind me, I've got the Rottler CNC hone there, 6-stone diamond head. And we're going to bring Ed Keebler, I believe, we're going to bring over. And then, of course, me and Lake will be there. And we're going to spend probably the first half or third of the day in the classroom, talking on the chalkboard, looking at slides, looking at data. But like so many things, you can read about it, you can watch a video about it, you can talk about it. But man, once you finally get your hands on it and do it, you just learn better. So I always like to think about, if I wanted to ride a bike, I could watch all the videos on the internet about how to ride a bike. But I'll tell you what, till you sat on there and moved the pedals, you haven't really ridden a bike. And it doesn't take you very long to get it once you do hands-on. So what we're going to do is set up a block in here with I think we're going to have a couple of different sleeves in it. So different hardnesses. We're going to talk about different stones and loads and speeds and feeds and pressures and coolant versus oil. And, we're going to kind of walk through the whole thing, but we're just going to let you do it. And that's how you're going to learn. We're going to hone for a while, use the profilometer, look at how the same honing practice in a different cylinder material affects your outcome. And then we'll be able to change the outcome and really have a lot of fun learning how to hone blocks to get the most power.
Exactly. Because you got to make a recipe, right? We talk about this all the time. It's a recipe, and you've got to figure out what that right recipe is. I mean, even today here with Danny back there on his home, we came across that okay, when you put in that finer grit abrasive, guess what? You have to back that load down. Otherwise, you're going to take out too much material. We already did that, right? So when we're done doing this episode of Hidden Horsepower, we're going to go back to the hone and work on that again, because that's part of how you learn. If you don't have a hands-on opportunity like this, it can't happen,
Oh, we lost Ben. I don't know where he went. We temporarily lost Ben. We'll come back. He probably got a text message, right? Like, that's the way it goes. There he is. He's back. He's now
Sorry about that, guys. I had a delivery guy show up on me, and I didn't want him to be in our episode.
Aha, that works just fine as well. Honestly, I'm surprised that doesn't happen more. Hey, I wanted to shout out the guy that came up and said hi, named Dan Kanzler Automotive Racing Engines. Came up, said he loves the episodes, loves Hidden Horsepower, wants to come out, and he's going to try to hit the next Engine Performance Expo. So shout out to him. That is great stuff. Now, Ben, you sent a video of some valve spring stuff. I saw you do it on your social media as well. And frankly, I was fascinated. I'm wondering if I can roll the video and you can give us a little insight.
So I gave you this example of what not to do. This is a really bad example of what you want your valve control to look like. So if you want to play that, I'll talk you through a couple things.
Okay, I'm going to try to bring your mic up over the top of it. Hopefully that works. If it doesn't, then we'll talk about it afterwards. Here it comes.
Okay, sounds good. So
you're good. Go for it.
Here. If you can hear me, there's a couple things here. So this is 12,000 frames per second of capture rate, and the engine's at 10,000 revolutions per minute. So a couple things. If you look at the spring, it's got a bunch of surge and coil clash. So it's hard to explain just how terrible the noise that makes is when you're actually running. But if you also watch the one that would be like on the left side of your screen, there might be the right side of your screen, the one nearest to you, you can see when it comes back to the seat, you can actually see the valve bounce off the seat and almost spits the lash cap out underneath the roller there on the rock arm. If you had a little bit more valve lash, it would quite easily spit that lash cap out of there, and boy, you'd be in big trouble. So this is what we don't want them to do. Now, the spring's moving around like that a lot, quite often, but when they start getting really violent like that, and it's actually pulling the lock and the retainer slightly off, we are moments away from catastrophe. This one did not end in catastrophe, thankfully. But the reason that we started doing it this way, Joe, was that in the olden days, like a year ago, we were really, really fancy with our laser, where we can put the laser in and watch the valve motion. And so from the piston's point of view, we can see what the valve is doing. And there's often times where you go, man, this thing's fantastic. It's amazing. It works great. And then we would film the spring, and you realize that the valve motion was okay, but holy cow, the spring was wildly out of control. Other times, the spring is perfectly happy dynamically, but it just doesn't have enough load. So you see the valve motion gets out of control. So really, we learned that we had to have both. We have to have a visual and a sort of data-driven approach to getting the valve train correct. And so there's a lot that you can actually see here. In some of the frames, you can actually look at the upper left corner of that rocker arm and see the shaft is trying to pull out of the stand. So, sorry. No, hang on, guys.
No, that's fine. That's fine. We'll pull Ben out. I could watch this all day. Like, honestly, like this kind of slow motion shots. I could watch this all day because I don't even know where to look. Like, I'm looking at everything and I'm seeing all this different stuff. Obviously, we're all fascinated by the internal combustion engine and the timing of it all. But this at 12,000 frames per second, to be able to see what's going on, and this thing's all over the place. This example.
Well, that's like Ben said. The power of his system is that not only are you using the laser to measure the valve motion from the piston's perspective, now you have the camera to come back and look at it from the valve spring's perspective and see what's going on. That way, I'm sure the next thing he's going to be having to do is, okay, as we run the Spintron and we're making all the gear shifts, we're going to see what's the spring doing with each of those shifts. Not only what the valve doing, but trying to have that ability to see what's happening and also measure. It's almost like we were doing with the profilometer and the microscope, is it gives you a 3D picture of what's going on with the high-speed camera and the laser with the valve, with the Spintron. Now you can really create this 3D picture of what's happening in my valve train to make sure you get good valve train control, not just for power, but also for durability. You can see all that with that setup. It's quite amazing.
So, and then Joe, go back to the picture with the black background and the yellow trace at the top.
Yes.
So to add to this, what we're doing here, if you look, so instead of just doing the typical dyno pull, you start at 3,000 and pull to 9,000 or whatever, this is actually a simulation that we took from the racetrack. Like, we took the data log from the racetrack and recreated it there on the Spintron. And what's interesting about that is before we had the ability to do this, we really could only look at the valve train in one direction. So accelerating. So you could accelerate slow, you accelerate fast, but we couldn't decelerate. And when you look at the data in your race pack, you can do what's called creating a math channel, and you can sort of take the derivative of your engine speed or the change in engine speed over time. And what you find is in a pretty fast car, let's take, for example, like a pro stock car. Those cars might accelerate at upwards of 4,000 to 5,000 RPMs per second in low gear. And then, of course, in second and third and fourth and fifth, the rate of acceleration goes down. But what a lot of people don't ever consider is that when you change gears on that Liberty 5-speed transmission, you'll see as much as like negative 15 to 18,000 RPMs. It goes backwards like 3 or 4 times faster than it was accelerating. And so a while back, somewhere around the end of 2019, we started to clue into what was happening there, and the valve train getting upset at the bottom of that gear change and going, if we could design valve trains that behaved better in that negative transient, the car might accelerate better. And so we've made huge gains in the vehicle performance that you couldn't necessarily even see on the dyno, because the dyno just goes burp straight up. But you would go, well, it's not really that much different on the dyno. You put it in the car, and the car was way faster. And so the reason that it was difficult to do that kind of testing before, like on the Spintron, was that the Spintron's a big electric motor. And so you put current into it and the motor spins, and that spins your engine so you can measure everything. If you try to slow down quickly, though, you take the power away and you slow that electric motor down, what happens is you get a 75 horsepower DC generator, because it's a 75 horsepower AC motor. And then when it starts slowing down, it starts generating, voltage. So if you're not careful, if you slow down too quickly, that voltage coming out of the motor will try to shut your drive down and basically like turn off your spintron. So you can't decelerate very quickly. Well, what I did was I went and bought what's called a DC chopper or a braking module. And what this thing does is it senses when you slow the electric motor down and it starts generating lots of voltage, it senses that and will nearly instantaneously switch that DC voltage away from the drive and into this giant bank of resistors that I have bolted to the wall now. And so now I have effectively a giant resistor braking module, so we can make the thing literally do gear changes. Like we can't go quite as fast as the car because we don't have that mechanical leverage, but you can make extremely hard and fast negative gear changes now. And sure enough, the data was showing why we were seeing those improvements on the track. And so I probably don't have enough time today to like really nitpick and go through all that data why, but we will get some time to do that in the class. But what we found was, we sort of, over the last 20, 30 years, we've learned how to put a camshaft in the engine that gives us the best power on the dyno. But now we're learning that what makes the most power on the dyno maybe isn't the right thing for what makes the car go down the track. And I know that we've sort of always known that, but you only knew it because you had all these 30 years of experience and you just sort of knew what not to do. Nobody could ever tell me why. Now we can measure it, we can manage it, and we can manipulate it. And so now we can make it do what we want when we want. It's really exciting time to be working on valve trains and camshafts and cylinder heads and fast engine stuff.
Lake, wow, that's just amazing. Hey, I want to jump in here because we are showing a lot of visuals and people might be wondering, like, what are they doing? This is an audio podcast. And yes, it is an audio podcast for people that are going over the road and driving and listening and all of that. But on this particular episode, we wanted to show these visuals. They are available. You can see them on the Hidden Horsepower, the Total Seal YouTube channel, which Lake has done a great job of bringing on subscribers. So you'll be able to see it there. It will also appear in our Facebook page and group. So all you have to do is when you get off the road or out of the shop and you can actually go and pay attention to something, you'll want to go back and check out this episode visually as well. So you can see some of these graphs and charts and even the valve spring video while we were talking over it. Just to see it in slow motion was really amazing. You're going to want to do that, guys. I know a lot of our guys are audio only. I'm an audio only guy. I listen to a lot of stuff. And when they're talking about something I can't see, I get annoyed. So I just wanted to let you guys know you will be able to see this stuff. You just got to go to the YouTube channel.
A picture is worth 1,000 words, Joe. When we're trying to explain a complex topic like that, as soon as you see it, it's like, oh, okay, I get it.
Exactly. Walk us through these other photographs and that way, like obviously this is just Randy Neal's amazing balancing machine, and we're
It is, but I don't want to pass too quickly there because I told Randy when we made the deal to get the machine here, I was skeptical, Joe. To me, crank balancing was always kind of like junk science, right? Like same thing. Nobody could give you a straight answer. Do you balance it 50%, negative 1%? There's all these opinions and nobody had any data. What I really like about what Randy's done with his machine there is he's made it so that you can get data. For example, I can now with the machine, I can now, balance a crankshaft or check the balance of a crankshaft and see how far it is out of balance, which frankly we could always do before. But what he's done is gone to the next level and said, okay, if you show me the out of balance, I'll show you how much force that is at any given engine speed you're going to run. So you might say, oh, this thing's only got 9 grams of imbalance, big deal. And Randy goes, yeah, it is a big deal at 10,000 RPM when that becomes 800 pounds of force on the crankshaft 66 times per second, like a jackhammer. And it was like, to me, that was like, it was this eye-opening, like, okay, now it's not junk science anymore. Now, again, we got to be able to measure it so we can manage it, so we can manipulate it. And if we can't do those things, then it is just sort of religious, because I said so ology. And that was what I really wanted to change when we started building the school. And that's why Randy's balancer ended up here, because it was the first time somebody could actually put numbers on something and say, let me show you why that 8 grams or 9 grams or whatever your number is. Let me show you why that isn't what you want, instead of just, well, I don't know, that's just what everybody does.
Copy that. And one of the great conversations I heard at the Engine Performance Expo, as I would go out when you guys were doing your thing and maybe get a beverage, sit down at one of the tables and just eavesdrop, was a conversation about balancing engines. And so I did my best, but and how, you know, whether or not you're using a vacuum pump and how that can change balance. And my mind was blown. And there's a lot going on in there. Certainly.
There's so many variables. I think that's what's exciting about engines, is the engine really is a series of dependent events that are connected together. You can never change just one little thing and have it not affect so many other things. You know, like you said, just putting a vacuum pump and how that affects the what's happening in the oil. I hate to say oil pan, but crankcase, right? Mm-hmm. It's amazing how the smallest little differences, you know, if you have a little bit more ring blow by in one cylinder than the other, then how hard that cylinder is pressing down on the crankshaft in that 90-degree phase. Well, if it's harder or less hard than the others, now you've got this torsional twisting happening. I think Randy calls that a second order vibration in the crankshaft. And it starts getting sort of mind-boggling of how precisely we need to try to control all these different variables. And you know, it's balance, it's ring seal, it's oil chemistry, it's, you know, combustion technology, it's airflow, it's all these things. You don't get to just change one. It always affects something else. And that's really what keeps this fun. I promise you, I would get bored really fast if you could just design the engine with a calculator and have it hit the dead center, you know, of your bullseye every time. Part of what makes this fun is the not knowing.
Absolutely. It's funny, when we were doing some of the stuff for Dad's engine here recently, Joe, we were over at Roush Yates, and Jeff Clark was talking some things, and we got talking about, you know, combustion analysis, and of course they were excited about what we were doing with Dad's engine and everything, and he just kind of made this offhand comment and said, "Oh yeah, I remember we really started getting into combustion analysis. We got this idea that we need to make every cylinder run the same. That would be the ideal thing, is, okay, try to figure out what's the best cylinder or whatever, but then we'll come up with an average and try to get all of them to be the same." So the engine wanted to beat itself apart if they made them all the same. He said, actually ran better, just let the good ones be good. Make the good one as good as it can be. And the ones that are dogs, just let them be dogs. Don't worry about it. Don't try to make them all the same, because the engine runs worse and tries to kill itself. And you're like, what? That's crazy. You would never think about that. You think, oh, you want to make them all the same. It's like, well, no, just let the best be the best. And then just help the ones that are struggling, but let them be different. It's okay.
Very interesting.
Yeah, it's almost impossible to get them all to be the same anyway. You're just going to have good ones and bad ones, and you just got to make each one be as good as it can be.
But it's not always the same.
About that video,
right?
Joe.
A couple of guys.
Yeah,
which one?
Pull up the video where you see the engine, and we start off on one side, and you see the headers on one side, and we go around to the other side of the engine. Yeah. So as you can see, there's some headers right there. Now we get around the other side of the engine. Those are different headers. Ben, why don't you explain what we did and what we saw?
It's funny. I'm laughing because I forgot about this. In fact, twice earlier, Joe, you showed me this video and I missed that. If you look, they are different headers. On this side of the engine, they're long tube headers. And over here on this side of the engine, they're short tube headers. I'd forgotten that we'd done all this. So one of the first things that we learned doing combustion analysis was that we don't have one engine that's an 8-cylinder engine. What we have is 8 individual 1-cylinder engines. And so what we could see right away was that at various engine speeds and various, loads, the header was right for some cylinders and wrong for others. And so the first thing that we thought was, well, geez, the last thing this thing ever wants is equal length headers on every single cylinder. And so one of us, you, me, Ross, I can't remember, somebody had
this is Ross's idea, totally.
One of us had the idea of like, well, let's swap headers. And I think Ross said, well, why are we doing both of them? Let's just swap one header. So we ran this engine with you can actually see the cables there hanging out at the bottom. Those are combustion sensors. So each sensor is in there measuring the cylinder pressure and power and torque. And we figured out right away that like putting, a long header and a short header and which side of the engine put it on had a dramatic difference of the way the engine ran. And even that, like if you put the long one on the left and the short one on the right, and then you just reversed them, the engine was totally different again. It was totally not an easy just predict this is going to happen and it happens. And that sort of led us into thinking that, wow, what's really happening is the exhaust manifold or that runner is actually talking through the cylinder to the intake manifold. So it was affecting the entire engine operation depending on what you did with the header and where you did it. And so what we realized is you don't want 8 equal length headers. You really want 8 not equal length headers, and each one should be suited to that particular cylinder to make it as good as it could be. Of course, that led into, well, what about the intake, and what about the camshaft, and what about, pretty soon you're back to like square one starting over, but it was a really fun exercise.
Oh my goodness.
Back to, you can't just sit down at the calculator and just come up with the perfect engine and just be done. This is why we do this, is because it's fun, because it's an infinite set of variables just about almost always.
I'm sure people are out there and they're like watching this and they're very interested, but they're also like, these guys have got the best gig. Like, this is cool. You get to do crazy stuff like that.
It's good work if you can get it.
Next time you're going to put a Zoomy on the one side and see what happens, right?
Yeah. Yeah.
Oh.
That was actually a really fun thing, though, because it did teach us a lot about the engine. You know, I mean, if you, Joe, do you have one of the pictures of the combustion pressures up there anywhere?
I believe I do. Is this it? No,
It looks similar to that, but that's the valve train one.
No.
One more. Got another one with a black background?
I don't think I do. Maybe this one.
No, okay.
No.
I thought
I've got 5 photographs.
I'm sorry. Maybe it was the video that Lake sent.
Video is a video, yeah.
Okay,
We're
that I've got. Here it comes. Video that Lake sent. I think this is it.
The tension's building. The suspense
Here
is
we
killing.
go. Drama.
Oh, yeah, there you
There
go.
it is.
Okay, so what you're looking at there, Joe, is basically a playback of the combustion pressures. That looks like probably just one cylinder that we're looking at of the 8.
Mm-hmm.
But up at the top, you've got like the yellow line there is sort of like the sweep that we did on the dyno. But what's really interesting is down at the bottom. So that funky looking, those 2 loops, we call them. Can you see that all right?
Yes.
All right. So what you're looking at is the 4-stroke engine cycle in terms of cylinder pressure and volume. So the y-axis going up and down is how much pressure was in the cylinder. And the x-axis across the bottom is the volume. So over to the left would be top dead center, and over to the right is bottom dead center. So watch. If you follow that line, the lowest line there would be the intake stroke, starting on the left-hand side, moving over to the right. The line kind of swoops down and has like a belly. That's low cylinder pressure where we're filling the intake stroke, okay? We get to bottom dead center, and then it turns around and it goes back up in almost a straight line. That's the compression stroke there. Then we light the spark plug and we get the work there happening as it rounds the corner and down the expansion stroke, also a straight line. And then it turns the corner again and it pumps it all back out through the exhaust stroke. And so what happens is you get those loops. We call it the working loop and the pumping loop. So the top one, if you look from bottom dead center to top dead center, that straight line on the bottom, that's our compression stroke. And in that part of the cycle, the pistons are doing work on the gases that are in the cylinder. And then we convert those gases into heat energy, and the gases then expand as the piston's going down. The gases are now doing work on the piston. And so if we were to take the area of that upper loop, we could call that effective pressure or mean effective pressure. The average amount of pressure in the cycle across that stroke effectively shows us how much work we were doing to the crankshaft. So because of that, we could measure the actual torque the cylinder is producing. Now, that's not what we net, though, because there is a little bit of payback in that bottom loop. So the area of the bottom loop between the exhaust pressure being high and the intake pressure being low, you got to subtract that out. That would be our pumping losses. But if you take your pumping losses in that loop and subtract them from the work loop at the top, you get the net mean effective pressure. And that's how we can effectively measure each individual cylinder's power and torque. Now, here's what's cool about that is that's the power and torque for that single cylinder. But if we look at all 8 cylinders and add them all together, we get power and torque for the whole engine, except that it doesn't match the dyno. It doesn't match the dyno because there's taxes, there's friction that we have to pay from the cylinders out to the flywheel. Yeah. Now we have a way to measure the friction of the engine in real time. So things like how much oil you put in the engine, how much ring tension you have, how much, you know what I mean, valve spring pressures you're using. We have a way to measure, manage, and manipulate those losses in the engine. Look at Lake. He's excited, Joe.
Yeah, he got excited.
Right. This is why I love this. This is why I hang out with Ben, right? Is one, you learn something new every time. You hang out with Ben, you'll learn something new every time. But anyone that knows me knows that all the things he just said are the things I love the most, right? This is what gets me up in the morning, and it's like, let's go make something happen. Let's learn something. That's it, which is why it's you go to Lake Havasu, not just because you have to go through Vegas or the weather's really nice. We get to do this kind of thing, and you can break out all those variables, and you can see all this stuff. Like you said, measure, manage, manipulate. That's how you make power. That's how you win races. That's what makes this so much fun.
That's right. That's 100% right.
Well, that was pretty interesting. Just that it was multiple loops. It was kind of the journey of the situation, right? Watching it, it affect the gases, and then the gases affect the piston.
So what's really cool is then you look at, okay, so how could now I've measured it. So how do I manage it? How do I manipulate it? Well, you do that by changing those headers, for example. And that doesn't necessarily change, my spark timing or anything like that. But what it does change is the pumping loss or penalty that I would pay during that part of the stroke. So if I can use the header to reduce my pumping loss, I effectively gain power because I had to pay less in taxes. And so the measurement part was getting the sensors and the data acquisition and drilling the holes in the cylinder head and doing all that. The management and manipulation part comes from looking at understanding, disseminating, and applying the data, right? And so without that data, all we're doing is guessing. I don't care who you are, what you do, all you're really doing is guessing without the data. And so, like you mentioned something earlier, and I was going to say something, but I got off track. But we talk a lot about how it can be frustrating for people in this industry to look at stuff like that and go, well, yeah, sure, you guys have $75,000 worth of sensors you can do, but how's a regular guy supposed to be able to do that? Well, the answer is come here and learn with us. Like, I love that you said every time you come here, you learn, because I do too. So the reality is, if you come here, whether in a class or whether you're Lake and you come hang out, you're going to learn at the speed of Ben, because every single day I show up here, I'm learning something. And so every single day I'm turning right around and sharing that with our Delta Lambda group, with our social media, with our classes, with our competition engine development. Like, I didn't build this place on a foundation of secrets. I literally built this place so that I could share the things that get me excited. Like you said, you wake up every morning, it makes you want to go into work. Man, I'm the same way, except I also toss and turn all night thinking about it. Can't wait to get here the next day and go find out more stuff. It's hard not to be affected by that. What's the right word? Like the culture as you get here, right? Like it's like infectious. You can't come here and not want to go explore and try something and find something new. And what about this? And how about that? And the cool thing is we have a lot of data. So when you ask a question, you don't get a, look at the floor and shuffle your feet. Oh, shucks, I don't know. I guess you just sort of have to know. You go, hey, let me pull up some data and show you. Or, you know what? I'm not really sure, but let's set up a test and get data to find out.
Exactly. Well, and that's EFI University, right? It's like a university is supposed to be a place of higher learning. And in theory, certainly originally, when you went to that place, you're supposed to have that kind of atmosphere where people are focused on exactly that, learning about stuff that they're interested in and that they want to learn, and they can take it away and take it back home and use it in their lives.
Well, and our job is to make it interesting enough that you want to learn. I distinctly remember 10th grade geometry class, rolling my eyes going, when am I ever going to use this? This is the dumbest stuff ever. Joke was on me, right? Like, I use it every day now. But beyond that, if somebody had told me in 10th grade all the cool things you can do with geometry to make engines faster, I would have paid attention. And so now what I do at my school is I try to find really cool ways to help people learn really complicated things, but make them simple and small bite-sized morsels that you can actually understand and use, because you want to go home and be better. You want to go home and apply it and have fun with it, enjoy it. We're not trying to like show you all our cool stuff and go, well, you're never going to be as cool as we are. That's not the point. No. The point is, hey, we made the investment to build this facility so that you can benefit from it. That's why you should come here.
Great stuff.
And the truth of that is the Delta Lambda group. When we got together at PRI, just walking around the room with all the Delta Lambdas in there and seeing that they are empowering each other. They're doing it. They're not just talking about it. They're doing it. It's what education should be, what a good university should be, is that it inspires you, it educates you, but then you go and do it. That's the whole point of,
the fraternity.
kind of bringing it together. Right? The whole idea of hidden horsepower is about teaching people, right? Well, we're not doing ourselves or anyone who's a hidden horsepower follower justice if we're not giving them the opportunity to go to the next level, to go to the competition engine development class, to go to the hands-on honing class. If you want to keep progressing, you got to keep doing, which is why we're doing this episode and talking about these things.
And I hate to be, I don't want this to come off and sound jerky or arrogant or whatever, but it's like everything else. There's always going to be a million reasons why you can't make the class, right? Like it costs X amount of dollars. I got to travel. I got to miss work. Believe me, there's never going to be a shortage of excuses or reasons not to push yourself and move forward. But for the few people that are dire, desperate and ready to figure out how to go to the next level, man, it's really like the cheapest thing you could ever do. It's such a launch pad, because you can probably testify this more than me, because I think I'm just bragging about our place, but you cannot come to EFI University for an hour, let alone 3 days, and not walk away with a completely different perspective about engines. I promise you that. And you could, like I said, you can probably say that better than I can because I live here, but man.
Well, I'll say this. You've only invited me to come see your place once. And that was, I don't know how many years ago. Feels like it's probably 10 years ago. You invited me to come see it once. I've just kept on coming back and inviting myself back for 10 years. And I have not gone a year. There's me, even during the lockdown, right? I showed up in 2 places during the lockdown year. I went to Shavers and I went to Ben's. Yeah. Travel restrictions be damned. I was going anyway, buddy. And so I keep coming back. And there's a reason I keep coming back.
Yeah, that's high praise. I appreciate that. I never forget the first time you came here. I didn't really know you. We'd met, I think, maybe at, I don't know, SEMA or PRI or something, like one of the trade shows. And, then you reached out and said, hey, I'm going to be in town. I want to come visit, and at that time it was like, man, this is like Speed Junior, like everybody sweep the floors and look busy, and I just remember like the first time you showed up, you like walked in the door and you set your briefcase down and you just kind of went, this place is legit. And I was like, that was a pretty high compliment. I knew then, like, okay, we're going the right way. Keep doing what we're doing, But yeah, you're right. I've only ever invited you once, but it's your second home, really. So no invitation needed.
All right, so I got to see this place. Is really the answer to the deal.
Pretty much
at some point.
Absolutely.
Now there's one more video lake. It's the thing that probably people will enjoy the most.
Play it.
You guys making a poll?
Oh yeah.
Here, you guys, if you want to walk us through, we just want to enjoy it.
This is the Engine Performance Expo LS.
I think that was about 9,100 RPM or something.
Yeah, I was about to say that's 20 pounds of boost at 9,000 something RPM, just 1,200 something horsepower.
Yeah, pretty cool. I think by the time it was over, we were turning that thing 9,150, 9,200, something like that. About 22 and a half pounds of boost. I think we made 1327 ultimately with that thing.
Yeah, 1327 was the best run. That one there popped up, I think, if I look by screen right, it looks like 1289. Here's the crazy thing, Joe. Talking about the combustion analysis stuff. If we didn't have in-cylinder combustion analysis on that engine, we probably would have capped out somewhere around like 1,100 horsepower. But Ben just relied on
1150 or 1160, and we were looking at each other going, man, this sucks. Like, we got to be able to do better than that. And you're right. We just started tuning on it. It was like, don't panic. Let's work on it. And yeah, we found a ton of power in that thing.
Just trusting the data, what it was telling us. I remember you said we basically violated all the cardinal rules of tuning on the last day in terms of, what your retard should be versus how much boost you're making. Like, we broke every one of those rules on the last day. But the coolest thing was, not only did you make 1,327 horsepower, we made like 13 runs over 1,250 horsepower, with the engine making like 1,680 something in cylinder.
Yeah.
But you can see every cylinder. And we know that we'd never hurt any cylinder because you can see every single cylinder. So we literally made whatever 1,300 horsepower, basically times 13 runs, how much power that was. That's incredible to have that level of power and consistency from all the shelf parts. Like, there's not a single part in that engine other than the connecting rods, because it's a weird deck height block that was custom. They're all shelf parts.
Yeah. So being able to, I remember having that like gut check moment where we looked at each other and it's like, all right, do we trust the data or not? Do we just do it the old fashioned way and say, I don't know, this is the way we've always done it? Or do we trust the data? So the risk is we trust the data and the data is wrong and we hurt our precious engine. But the reward could potentially be huge. And I want to say we were somewhere in like the 1180-ish, 1185 power. And it was like, look, we either trust the data or we don't. And we just started getting after it. And like you said, I think 13 plus runs over 9,000 RPM and over 20 pounds of boost, making at the crankshaft over 1,250 horsepower, and on average 1,280 to 1,300. But like you pointed out, that thing was making almost 1,700 horsepower inside the combustion chambers. We're just giving away 300 or so of friction to turn the blower and move the pistons and all that. But you still got to make that cylinder pressure. You still have to seal that cylinder pressure. The rings have to work. You can't mess up the tune-up and knock the rings out of the thing and expect it to make power. The fact that we did that over, and it almost got boring, because we trusted the data.
Well, we hit the limit of the engine, right? We found out, okay, back to the pressure transducers and what it was telling us, we couldn't put more air in the engine because we couldn't get it out. We basically hit the limit of those headers. And we're like, we can't make any more power than that because we can't get the air out now. We're done.
Yep. So interestingly, that's what makes this fun. So then you go back and you work on your headers and go, all right, we got this good. So now I need to turn the boost up, and then you get, you just chase your tail, and it's pretty soon you're at 1,500 horsepower, so exactly. Lots of fun.
Amazing.
Well, that's going to be the work we do this year for the next Engine Performance Expo. Okay, that's where we left off. Now what do we do next?
Lake, is this thing going to end up in a race car somewhere at some point?
We're going to have to do something, right? I think we talked about this thing being a drag week type engine in the very beginning. I think at some point we have to do that. It's got to be like a drag week, sick week. We got to do something. We got to put it in a car at some point and go fast, right? We're going to put my dad's engine in a car and go fast. So we got to go put this thing in a car and go fast.
Joe, we just volunteer to drive it. Are you in?
Yeah, I'm the guy. I mean, maybe. I'm a little nervous, honestly. Like, I volunteer because the answer is always yes. The question's like that, yes. But now I'm already thinking of it. There will be some stress. Because there's a lot of hard work that goes to it. But I'll still do it.
If we put it in a car, so you don't have to be scared, right?
Speaking of your dad's engine going fast, I know that video is out. I have yet to see that, Lake.
Oh yeah, watch it. You got to go watch it.
I hear it's great. Like, that's one that I want to sit down. It's not a watch or listen while I'm doing something else in the background. That is a focus deal. Feel free to promote where it is for those that don't know. But Lake's dad's engine ended up back in a car, and his dad back behind the wheel, from what I understand.
Well, that's what it's going to end up being, right? So the video that just came out is Stapleton 42. Is the YouTube channel you can go to. So that's Stapleton 42. It's probably the first one up there, or you just want to go to YouTube, type in Lake Speed, and it's going to be the first thing that pops up. It's taking that engine that was in the shop for 18 years of sitting on the floor, and then we took it out. We took it over to Pro Motor, Dennis Borman and those guys, and we dynoed it, and it was way down on power. And then we basically applied all these same things that we've been talking about today, that we talk about in the class. We applied it to it, kept the same heads, same block, same manifold, same crank, same rod, same oil pump, same oil pan, blah, blah, blah. You get the idea. We just changed the stuff inside and modernized it inside and applied these techniques to it. And it went from making basically 480 horsepower this summer to making 780 horsepower this January with all those same parts, but just modern internals.
Amazing. Simply amazing. All right, guys, final thoughts as we wind up what has been the first studio episode of Hidden Horsepower for 2023. We're going to have celebrity engine builders. We're going to have racers. Who knows what we're going to have, Lake, as the year goes on. Right in the middle of the year, right? Like, we always come up with great ideas. So what do you have in mind?
Well, we have all the episodes we filmed at PRI. So we're going to have a whole run here coming up. An update from Mike Copeland, Pat Musey, and Tron Brown. I mean, we've got some really great. I mean, I listened to the Gary Williams episode as I was working on it the other night, Joe. Gary Williams' stories were amazing. So we've got some really great episodes from the PRI show that have been recorded. Those will stop dropping really soon. So basically right after this, we're going to get a little bit of PRI, and then we've got all kinds of new stuff. I know Keith Jones has been cooking up some ideas with some folks. So it's going to be another great year for more hidden horsepower.
And I want to do some more Q&A episodes this year. The Q&A ones that we did were at the very start of the Hidden Horsepower run. I think people didn't fully understand exactly how wide open this thing can be for a Q&A. And so with the social media and all the accounts up there, I think we can solicit some questions from the audience as well and just kind of put them towards you guys as well. Final thoughts, Ben, got anything else you want to throw out there before we wrap this thing up? Is there anything that we failed to cover, Lake, that you had a plan to cover on this episode, guys?
I think we covered all the cool stuff. We wanted to brag about our shop. We wanted to talk about the classes we can help people with. And obviously 2023 for us is going to be great working on this engine. We have a whole bag of tricks lined up for how we're going to make more power. So being able to get to work with my buddy Lake all year on that and then show it off next year is going to be awesome. And who knows what else we're going to learn as we go. But I promise you, we're going to be learning.
That is awesome. Lake?
Absolutely. So come join us. If you want to come hang out and join us on the effort, please do so.
Yep. And the good news is that everybody can go back and watch this over and over again. But one more time for the classes, they start in March 1st through 3rd, 2023 out there. That is the first one. There are limited seats remaining. You can go to EFI101.com. But there are multiple classes and multiple courses, right? So give those dates once again for each.
So March 1st through the 3rd is the next competition engine development class. Then we'll have the following week from that, we're actually going to do our EFI tuning course as well, called ACP. And there's some seats left available. I think there's 1 or 2 seats left in that one. Then come April 22nd, we're going to do the Rottler Total Seal EFI University Straub Technologies honing course. So that'll be here. And then is it June, what'd you say, 9th? June 9th was the one in Tennessee?
It's like 9th, 10th, somewhere around there. It's the same week as the Bristol NHRA race. We'll have the honing class at Straub's, which is 7 miles from Bristol Motor Speedway.
Yes, and Bristol Dragway as well. NASCAR guy.
That's great.
And I'll be there as well. Hopefully I'll get in a little bit early and can go kind of check that out. Fly.
Yeah, man.
You got to run the home.
Oh my
exactly.
God. Speaking
because I think we'll have your block there by then. I think that's kind of the plan, wasn't it, Joe? Was to have your block for your have it back from Gary and have it there, and we're going to hone your block while we're there.
I would hope so. You and Gary were hatching all kinds of plans. We went out to dinner at the expo. Everybody knows that there is a social scene to that as well. And all I know is that Gary and Lake, they made a bunch of plans, and I don't even know what they are. I know that it's all my stuff. But
it'll probably work out in your favor, though, Joe.
That's why it's just like, and so just a quick inside story for the two of you and the benefit of the audience. You guys might find this interesting, but of course we're talking about an engine and a bracket car of mine that I'm trying to like resuscitate. And Lake, so what? You've got something that's old and you want to make it new? That's great. That's right in that's my wheelhouse. And so it's kind of being taken over. Well, I'm going to Kansas in 2 weeks for an unrelated NHRA event. So I thought it was very important for Gary Stinnett to get my engine prior to me going there so I can pop in and check it out. So for the past 2 weeks of my life, I have been thrashing to do all the things to ship an engine, which I have never done. Shipped an engine. What do? You know, I'm getting a pallet. I'm getting an engine cradle. I'm building a crate. I'm throwing everything in the crate. I'm making logistical plans. And the engine arrived at Gary's on Friday while I was at Orlando Speed World for NHRA. And he's taking pictures of it. And he sent me a list of inventory. Everything made it. And it got real. When he sent me the photographs, I felt this sensation of, oh, man, it's on. So I'm super excited about what's going on with this. And, you know, whether or not we could pick up power or all that, it's just that I know that I can trust the people that are involved. And that's what makes me super excited. So there's
no pressure, but so far Lake's average is picking up 300 horsepower on each engine that he touches. So
got my work cut out this time.
I don't know. I have no idea. It's been sitting around a long time, and I can visually tell you there was a bunch of things wrong with it that need to be fixed. So we'll see.
The worse it is, the easier it is to find those 300, right? So.
Strader. But I wasn't going to do anything to it. All right, gentlemen. Thank you very much. Ben, excellent work. That was amazing.
You're welcome. Great to be
There
here,
he
guys.
goes. Ben Strader, EFI University, and Lake. Final thought for the audience out there. Hey, if they want to connect with Total Seal, by the way, the reason we're doing all this is to educate people about Total Seal, their technology, their commitment to educate, so people, when they need piston rings, they buy them from you guys. If someone's got a project,
possible, right?
That's kind of the number one reason we're doing all this, is to sell piston rings. People got project engines. They got a question. What should they do?
They should call 623-587-7400. Talk to one of the guys, Keith, Kevin, Bobby, or August, any of those guys out there. They can help you out with your project. Just tell them what your intention is. They can help you get in the right direction. Or if you want to go to totalseal.com, if you already kind of know what you want, you have an idea, you can go there, order it right there, or from one of our distributors, that's fine. So, ideas, like you said, we're having fun doing this stuff, but the only way we can pay for all these things is selling piston rings. But that's the nice thing that we're doing, is we're giving back. We're not just saying, hey, buy some piston rings and then we can go buy a boat. No, what we're doing is, hey, buy some piston rings so we can do more projects, so we can teach you better, so that we're all getting better and getting smarter together.
And Matt has said on this show that, even if you have a question, like eventually, if you get good service from Total Seal, if a question gets answered, you spend a little time learning something, your next engine, you're going to need rings at some point. You'll come back to Total Seal. And I think that is great news. I'm excited.
Well, we kind of think we can help you make more power. We're pretty sure that if you use Total Seal rings, you're probably going to make more power. If you follow our recipe, we're probably going to help you make more power and more longevity. So in the end, it kind of works out in your favor to buy our rings.
It's simple as that. Lake, great job.
Thanks, sir.
He is Lake Speed Jr. And I am Joe Castello. You can follow me, WFO Joe. I also do a podcast called WFO Radio, the studio in which I am in. We talk to drag racers. That's how I met all of these guys. And it has just been so amazing. We are just getting started with Hidden Horsepower. So subscribe, click the bell if you're watching on YouTube. If you're an audio-only podcast listener, you're going to want to go find this episode, guys. But we got plenty audio episodes coming at you here in 2023, and it is going to be great. Thanks to Lake Speed, thanks to Ben Strader, and thanks to everyone else out there. Power presented by Total Seal. We'll see you next time.